We're working our way through the 2019 AP Calculus AB free response questions. We're working our way up to question number 5, and it is the most classic topic that you'll see on the free response section, and that is the area and volume question. We're going to try to be real aggressive and go for our 9 here on this question, and I know you can do it. Let's see if we can shimmy down here a little bit, see what we got ourselves into. Now, this is a non-calculator question since it's number 5. And we've been given 2 functions. And now we're going to try to sort out who's who here. Now, this g of x function is made up of cosine. And so that's going to be this bear right along here. So there's your g function. Okay, now this other one, h, it's a quadratic function. And the coefficient 2 is negative. So it's opening downward. And so that's how you kind of sort them out. One of them's cosine. The other one's a upside down quadratic. And they're bounded between, we'll say, x equals 0 here and x equals 2. So right out of the gates, we want to try to find the area of region R. And anytime we're looking for area, it's pretty nice. We're thinking it's really the upper function, whoopsie daisy, minus the lower function with respect to x, most likely, assuming we're going up to down. We've got bounds from x equals a to x equals b. So in this particular case, I want the integral from 0 to 2. And I want h of x, who's on top, minus g of x, who's on the bottom. Now, this is non-calculator, and that may intimidate you a little bit, but I promise we're going to be okay. It is a grinder, though, and the good news is parts B and C get pretty easy relative to this one. At least they're set up only for the most part. All right, so the integral from 0 to 2, I'm going to write these functions out. So h is going to be 6 minus 2 quantity x minus 1 squared, minus the g of x function. And I'm going to be really careful to distribute this negative sign, and you'll probably see me combine like terms. So I'm thinking, okay, let's do the integral from 0 to 2 of 8. That's combining the 6 and this 2, minus 2 quantity x minus 1 squared, minus 3 cosine of pi over 2x dx. And what I like to do in this case is I'm going to rewrite this as 3 separate integrals just to kind of compartmentalize it a little bit and so I don't get too overwhelmed. So I've got this integral of 8 minus, I'll pull out the 2, the integral of the quadratic function. And pull out that negative 3, and then I'm going to do the integral of this cosine function. And I'm just breaking it down into more manageable pieces, and I'm basically treating them as 3 separate integrals, 3 separate problems. Now this first one, the antiderivative is simply 8x, and we've got bounds from 0 to 2. So that's going to end up making 16 minus 0 by the time I plug in those bounds. Now what we've got cooking over here is if you're real good at U-sub, what you're probably visualizing is letting u equal that inner function. And so when you integrate a u squared, you're going to get 1/3 u cubed. So that makes 2/3 u cubed, x minus 1 cubed, and the bounds are from 0 to 2. All right, so if I plug in a 2, I'm going to get 2/3. And if I plug in a 0, I'm going to get, negative 2/3 there. So I'm going to end up adding those bears together here in a second. Let's see, I got a 3 here. Let's see. So again, I might do, because I got a little mini inner function here, I'm going to let u equal pi over 2 times x, and the derivative of that is pi over 2 dx. Eventually, what's going to happen, if I like to solve for the dx and then substitute right here. So what are you substituting for that dx? You're substituting 2 over pi times du. And then by the time we integrate that, we're going to get, our coefficient is going to be 6 over pi. The integral of cosine is going to be sine in this case. And then you've got that inner function. Now, I went through that process a lot faster than I normally would. So if you have any doubts, and you can do this anytime you're integrating, you say, man, I don't know if I got that right. Try deriving this function right here. Try taking its derivative, and hopefully the derivative matches this function right here, and that'll give you a little more confidence that we did indeed integrate it correctly. Now, substituting a 2, in for x would make sine of pi, which turns out to be 0. And substituting a 0 for x would make sine of 0, which is 0 again. And when it's all said and done, we've got 16 minus, let's see, what's that going to be? 4/3. So we've got 48/3 minus 4/3, which makes 44/3 for the area of region R. I'll tell you what, it's going to get easier from there. It's going to get a little easier here. Okay. Now think of this. Treat region R as the base of some solid. Now, instead of telling us that there's going to be cross-sectional regions that are, squares or rectangles or some kind of triangle, they're just saying there's some unknown random shape whose cross-sectional area is given by this function right here. Okay, so here's the number one thing I want you to take away. Maybe the number one thing you're going to take away out of this entire problem is if we assume that a of x is just a general function that represents cross-sectional area, because this is what it always comes down to, no matter what the shapes are, there always comes down to cross-sectional area. We're going to say that the volume is always the integral of cross-sectional area 100% of the time, no matter what shape you're dealing with. So in this particular case, our volume is just going to be the integral from 0 to 2 of this 1 over x plus 3 function. For a little bit of overkill, maybe we're going to actually do that u sub, which is going to give you du over dx. So, and if I rewrote that integral in terms of u, let's see, the lower bound would be 3 because I'm substituting this 0 for this x. And then I'm going to substitute that 2 in for x to make the upper bound of 5. You've got 1 over u du, which is going to give you an antiderivative of ln of u. Notice how I've got everything in terms of u, so I can go ahead and substitute that 5, then substitute the 3. You don't have to do this last move, but if you want to get cute and use your natural log properties, you could combine it that way. All right, moving on here. Write, but do not solve. Those are my favorite words right there. Write, but do not evaluate an integral expression that gives the volume of the solid when it's rotated around the horizontal line y equals 6. So what we've got to decide here is, first of all, when I revolve it around that line, does it create a solid disk? Or does it create a washer where there's a little gap between the region and the axis of rotation? We're going to try to show you that this one creates a washer, and the general formula is going to be the integral from a to b with a coefficient of pi. You've got your outer radius squared minus your inner radius squared. And we're going to go ahead and try to, this always comes down to, are you comfortable finding the length of that outer radius, and are you comfortable finding the length of that inner radius? So let's go up here and take a look. Let's see. Okay. And I might try to clean this picture up a little bit here. All right. So let's say, where exactly is that y equals 6? 1, 2, 3, 4, 5. That's going to put me right about here. Okay. So right away, I'm thinking this is going to be a washer because there is a little bit of gap between the region R and that axis of rotation. And what I like to do here, and I know probably every classroom is a little different here, but I'm always picturing like some type of vertical slice in that region that's perpendicular to the axis of rotation. And first thing I'm going to do is the distance from this curve here, because this curve's further away from the axis of rotation now, how far is that from the axis of rotation itself? That's going to be the length of your outer radius. And then secondly, the closer of the two curves, that little hiccup right there is going to be your inner radius. Now, how do you find the length of your outer radius? You simply you follow that squiggly bracket as you go upper minus lower. So it's going to be 6 minus g of x, which is that cosine function. And then the length of the inner radius is going to be, again, upper minus lower. It's always going to be upper minus lower as you're trying to find the length of, some gap. So it's going to be 6 minus h of x. And I'm going to go ahead and import those into my setup that I had written down here. Okay. So let's put the finishing touch. We know the volume is going to be pi because it's circular, 0 to 2. We've got 6 minus g of x as my outer radius. I've got 6 minus h of x as my inner radius. And that's all I've got to do because we've just got to do setup only. Does it get any better than that? All right. Hopefully I didn't go too fast through any of those sections, but certainly if I did, feel free to throw some comments in below, and then I'll try to add some commentary where we kind of tap the brakes a little bit and provide you some more insight and some more detail into some of those moves we made. If you found this video helpful, and I hope you did, we'd really appreciate it if you hit subscribe below and shared it with your friends as we all rev up and get ready to tackle this big bear called the AP exam. All right, folks, good luck.